Hi folks, and welcome back once again. So today we're going to be doing the final video I'm going to make on this Vertex printer. Another set of modifications to do to it today. I'm going to change the hot ends up here because I'm not quite happy with the performance of those for some E3Dv6 hot ends. So let's get in and have a look at exactly what we're going to be doing. So hopping over to Thingiverse, entering the search term of K8400 E3D. Gets us right to the page we need, and there's this design down here by a designer called Logmett. Actually this Logmett chap is called Boris Maisuradze. Some fantastic designs that Boris has done. In fact, I noticed when I was looking through his designs earlier, he was also the one who did the better wiring guides at the back of the printer, which I still haven't got around to fitting. Anyway, this is the design we're going to be taking a look at. I've been busy for the last week printing off the parts for this. So what this does is replace the default dual extruders on the top of the printer and let you use E3D ones instead. And unfortunately this does mean we have to make a small modification to the E3D parts to get everything to fit. But I'm going to get in and do that now. So let's start off and get all of these bits printed out. I've printed out these parts in a polycarbonate ABS blend by Ice Filaments. And I have to say, these are some fantastic looking parts. The surface finish on these is just amazing. Absolutely awesome. So you have to be a bit careful when you're printing these off, and the natural tendency is to get all the design files, arrange them on the print bed and hit print, but it's not a good idea. This fan mount here needs to be printed 100% infill because you're putting screws into these pillars, and they need to be as solid as possible or they'll break off. This part actually holds the E3D hot end in conjunction with these, and this bit wants 50% infill, very thick walls, because when the screws go in here you're relying on the layer adhesion to actually keep this closed. So this part needs to be absolutely as solid as possible. This piece is just an airflow duct and isn't too important at all. And these end clamps, again, not so critical on here, kind of 25% infill's fine for them. So I'm going to take the old head off the existing printer. I'll show you how it all goes together. So from the existing printer you will need to remove the little clip that holds the fan mount and the little fan, the hot ends themselves, the bracket for the hot ends, the little tube holder things, and a bunch of fixings that hold all that on together. Not going to be needing them anymore, so save them in a drawer for future use. Now, while I've got this on the desk, I want to talk about what's wrong with this original design of hot end that came with the K8400, and why I felt that changing to the all metal E3D hot ends would be an advantage. So we'll just pull this apart and I'll show you quite how this works. So we've got a small hole in the top of this plastic, I think it's called a heat break block, and inside this we're lined with a PTFE tube, which appears to be blocked on this one. There we go. That's kind of a good example of the problem with this design, in fact. That little plug was stuck in there. So what happens is the filament comes through here and then into the hot end there, goes through and gets extruded out the end. But when the printer does a retraction, it's pulling that heated filament back up into here. And if for any reason you actually stop the print part way through and this extruder's left hot, which is the default behaviour of the firmware on the K8400, as soon as you hit stop, this bit stays hot, all the fans switched off. The heat works its way back up, this filament becomes soft and then gets stuck inside the tube here, and you end up having to dismantle the whole nozzle to unclog it all. The other problem with this kind of hot end is this PTFE tube down inside here is only actually good to about 240, 250 degrees C, and at temperatures above that the plastic will start to degrade and give off nasty fumes. So if you want to work with any of the more specialist filaments like polycarbonate, nylon, or in fact this PC-ABS blend, then you need a hot end that can reach higher temperatures than this. And the E3D all metal hot end is good up to about 300 degrees C. So you might ask how I printed these polycarbonate bits or PC-ABS bits using these hot ends, and the answer is I didn't. And in fact, on my printer I already upgraded the hot ends a week ago, and since then I've been using the new hot ends to print out the polycarbonate versions to replace these PETG ones I printed before, which although they're quite nice quality prints, I figured a more rigid plastic would probably give better performance. And the polycarbonate's good up to about 150 degrees C, and this is good up to about 70. So although this has given me no problems whatsoever printed in PETG, just because the first thing I wanted to try out when I got this installed was printing in polycarbonate ABS blend, I reprinted all of these parts apart from this fan shroud at the top. So to maximise my chances of not having this kind of thing happen and the layers split apart when you put the screws in here, when you put the screws in here, this time around I'm just going to tap the holes with a tap and die set. And there we go. So with 4 proper threads inside there, that should significantly decrease the chances that when I put these screws in it'll force the layers apart, and in fact that screws in beautifully. So now we can get on and actually assemble this print head. You need to make a few modifications to the default E3D setup before you can actually fit it in. We used the same heater cartridges that came with the K8400, but having already cut the wires in the past, you just need to extend them out a bit to around 20 centimeters. And the same with the Thermistor wires on the E3D hot end. You need to extend them out. Now, I cut the built-in 2-pin connector off these when I did it, and I wouldn't advise anyone to do that. These Thermistor wires contain a single core copper cable, and it seems to have some kind of coating that means solder just will not stick to it. So extending these wires caused me a huge problem. But when you buy the thermistors from E3D, they actually come with a red-black extension cable anyway. So I'd advise just using that red-black cable and leave the existing connectors in place. You also need to get creative and make this little cutout here so that these E3D heat sinks will fit around the Y-axis bar on the printer itself. I did them in the shed. I used a Dremel to rough out the majority of the cuts and then sanded the remainder. I wrapped a piece of sandpaper around an 8mm threaded bar, put it in the vise, and then sanded that to the perfect profile. So printing this particular piece, this is the main body, caused me so many issues. The best I managed, this one was printed with the E3D hot ends, but the best I managed before that was this one, which had all sorts of problems with layer separation. And I'll throw in here a time lapse of the number of failures. I didn't even record all of them when I made this. I got fed up of putting the time lapse camera on, but you may have significant challenges getting this main body to print until you've upgraded it, bizarrely. Boris's design calls for a 20mm thick 40mm fan, and he's used quite a high power rated one. He uses one that's 12 volts, 0.24 amps. I must have around 30 of these fans kicking around the place. None of them whatsoever were right. And I tried looking up the specs on the fan that Boris had used, looked on Delta's website for it, couldn't find that particular model number at all. But I did find a 15mm version that they do now. So I went for the one with the highest static pressure and printed off this Ninjaflex Spacer, which should act as a bit of a sound dampener as well. So from one end to the other I'm still 20mm, and that fits in with Boris's design. So if you're interested, this is an AFB 0412 SHB, super high blow. This is the max power that they had. So I used that one instead. Okay, so let's get on with the assembly. This is the printer carriage with all the bits we don't need removed. Okay, so the original M3 locking nuts that held the top part all together fit into these holes quite nicely. And then this whole body section slides into here, which locks in with the old holes, and this will then sit on top of the old mounts, and then the screws go in upside down from the bottom rather than from the top like they used to. Now, in terms of levelling the relative position of these two nozzles, this is all down to the tightness of these screws on the bottom, and as you tighten one side or the other, you'll see this shift left or right ever so slightly. There's only fractions of a millimetre of play in it, but when you need to get them, the two nozzles at exactly the same height, this is how you do it. So I'm not going to tighten those up too much just at the moment. I'll tighten them more when I've actually got nozzles in place. I'm just going to get these in enough that they're biting into the threads properly for now. Okay, so with that done, the next thing we need to do is get our wires threaded through, ready for these hot ends. So there's wire ducts at the side of each of these, and if I can actually see, the wire ducts are further back. If I could see what I was doing, sorry, this is the perils of having the camera in the way. Yeah, the wire ducts are on the outside, so the wires thread through there and will come poking out the top. There we go. This will then clip into place like that. And then the clamps go on at the sides to hold everything into place. And they're held in with some M4 bolts. Okay, so now that the hot ends are screwed into place, I'm just using two of these gauge blocks to actually check the height of things respectively, and I can tell because I can hear it colliding that this nozzle on the left is slightly lower than the one on the right. So I'm just going to tighten up these screws on the right a bit to pull things back the other way. I'm going to tighten the other side down a bit to match, and I'll repeat this until everything seems to be perfect. Okay, so that seems good. And just feel that making contact on the left and just making contact on the right. So they should be perfectly aligned with each other. Boris's design calls for a small modification to this circuit board. So we have the fan power coming in from the main board, but that's at 15 volts. So what Velleman have done, I've just put a capacitor to smooth it off and a small resistor to drop the voltage down a little bit. Because we're using a higher current fan, Boris recommends changing this resistor to a 33 ohm 1 watt resistor, but I decided to go a different approach instead. So I just shorted across the pads for that resistor, and I'm using one of these little tiny variable voltage power DC-DC converters. It's just got a potentiometer there, and this thing will take anything up to about 45 volts in and give you any voltage you want out. So I thought I'd strap one to the side of my printer instead, and it lets me adjust the fan speed rather than having to do the solder job. And I can always reverse this later on and take this solder blob off if I want the old hot ends back. Boris's design calls for using 40mm M3 bolts, but I found they were about 10mm too long, so I cut the end off them down to about 30mm. So I'd recommend going with 30mm instead. And then I just put on my little Ninjaflex spacers. Drop the fan into place. These fans always blow air out of the side with the hub on, so that's the side that needs to point down to blow the air through the head. And then drop my gasket on to keep all the air blowing in the right direction and provide a bit of noise dampening. And that will then screw onto there. And with that in place, I'm just going to temporarily put a couple of bolts in here to hold this in the right spot while we wire all the connections in. So the connections on here are the extruder, the heater cartridge goes at the front, the thermistor goes in the middle, the fan goes at the back, and it's the same at the other side, but we've only got one fan to worry about now. Okay, so now we've got all our wires in place, we can take out these temporary screws and we can mount the fan shroud cover bit. And this has got 4 holes through that line up with the holes on this board and then end up in those pegs. So it's a bit of a fiddle to get it all in the right place, but it does go eventually. So the screws are in. All we need to do now is plug on the cable. Fits nicely, and Boris has very thoughtfully provided this cable retention bracket here so you can wrap a cable tie around the wires. I haven't done that just yet. Drop in our Bowden tubes, get rid of the cat hair, and pop on the little clips that E3D provide. Get the second tube in. Lock that in place. Getting close to done. Throw on these little shrouds, but actually before I do that I found I got slightly better thermal performance by cutting out, this is 1mm fibre blanket, ceramic fibre blanket that they use when they're making fireplaces and boilers, and I found that just slipping that in on the top of the heater block cuts down on a bit of the breeze that's blowing on it and lets it hold the temperature slightly better. I'll put the little silicone boots on there. And the final touch for up here is this fan duct, and I just have to say this is kind of a masterpiece of engineering. Boris has tapered the edges up at the top here, so you're absolutely guaranteed to get a superb fit where it mounts into the main body part. Okay, so round on the underside of the machine you will need to unplug the black and white wire from this point that's marked fan down at the bottom, and I've run them up to here instead to my little voltage regulator, and then this goes into the same input power on the board, the 15 volt in that comes out of that power supply. With the E3D hot ends, really they want continuous cooling regardless of whether the printer's printing or not, so it's just a lot easier to have the fan running all the time that the power is switched onto this machine, rather than having the software control that switches off the fan at inappropriate times. So that's the last modification for the hot end. So after having had a week or so to get used to this modified hot end, would I say it's worth it? Well, hell yeah. This thing's been awesome. The print quality went up, I've had no blocked nozzles, hitting stop in the middle of a print job doesn't automatically lead to a blocked nozzle, I'm able to print in high temperature filaments. Yeah, these things are great, absolutely totally well worth the modification. Okay, well that's it for this episode, folks. Hope you all enjoyed it. All that remains for me to say is once again a big thank you to the distributor Reichelt, who sent me this to have a play around with. None of the last 5 videos I think would have happened without them, so thank you Reichelt. I'll put links down to their website and to the product page for this in the description below. Coming up in the next one, we've got the contents of this box, which has been waiting for me to get into it for a good 3 months now, and a care package I received from IC Station, which is to help me out with whatever's in this box. So if you want to find out, tune in next time. Anyway, thanks again, see you next time, bye!